All right. Um, okay, so the last time we went through in part one, we went through these two menus here, the basic and the fuel. So now let's go over the ignition. The first one is mainly setup related, specific to the Buick ignition module or the TR6 module. So almost all of this you don't need to change. The main thing that you might want to play with on this screen is if you need to check your ignition timing to make sure it's accurate. Uh, Up here under fixed advance, right now it says use table, and that means use the ignition table right here. But we can fix it by changing it to fixed timing and putting 15. You could put anything in there, but we usually use 15 because that's a easy number to check on the Buick. Put it to 15 degrees and hit burn and start the car, and it'll be stuck on 15 degrees so that you can check it for accuracy. If it's off, if the balancer wheel is off a little bit, a couple degrees or however amount, high or low, this number down here, the tooth one angle, you can move that, bump it up or down a few degrees to correct the number. But like I said, almost everything else on here you don't need to mess with unless you change to a different style ignition system, like trying to control a coil pack directly or a coil near plug, that kind of thing. Dwell, you don't need to play with that with the normal ignition. Cold advance, this allows you to add spark advance if the coolant temperature is colder. And you might ask, why would I need to do that? Well, when an engine is cold, there's more friction. There are some other factors involved, but there's more friction and advancing the timing a little bit can help keep it going. MAT based timing retard. MAT is the manifold air temperature. This allows you to add retard, in other words, subtract some timing if the air temperature starts getting fairly hot. And by default, I have this on all zeros unless it starts getting much over 140 degrees. And you can see it slowly starts subtracting timing to help with detonation. Noise filtering, you don't really need to play with that unless you have a specific situation where you have some noise getting into the crank or cam signals. Knock sensor settings. So the ECU uses the stock knock sensor and the stock ESC module, which is a filter. It helps condition the knock signal before it gets to the ECU, just like the stock computer. And most of this is set up specific to this ECU, how it looks at that signal. In here, it says when you want the knock retard to be enabled. In general, I have it enabled all the time. The under 2,000 RPM, it's turned off because sometimes engines are noisy at idle and things like that. This is how many knock events need to occur before it'll start retarding timing. Depending on the engine, you might set it to 2 or 1. 1 is going to be more sensitive. If you have a noisy engine, you might set it to 2 or even 3 so that when there's little blips of noise, it doesn't immediately start retarding timing. This is the max amount of retard you can have. This is how often it checks and might add more retard. And these other settings have to do with how much it will retard in one step or how much it will add back once it already has retarded the timing. This table over here on the right, that isn't used when using the stock knock retard setup. This is used if you're using the internal knock filter within the ECU. In other words, you can do away with the Buick filter and connect the knock sensor directly to the ECU and then you would set this to internal. And then you'll see these turn off here because we're not using the stock setup. And in that case, you'll see when you set it to the internal, you'll see kind of noise, a normal amount of noise appear on this gauge when the engine's running. Maybe it's 30% or 40%. And if it knocks, this will go very high. There's a lot of settings involved in getting this set up right. So we may have to go over that in a different video or something, but there's some other settings involved with that. And then you would set up the table to say if the knock input exceeds, let's say for example 80%, then it would start retarding timing. So the on-off is for the stock style. These other knock settings, this ECU will look at when it will look for knock when it's most likely to occur. And so what this table on top is when will it start looking, when will it turn on the knock sensor and even start looking for knock? And right along here you can see it set at -10, and that's 10 degrees before top dead center. That's when it will start. In these other areas, there's never any knock isn't going to happen in there, so it's not going to look. The bottom table is once it starts looking for knock, how many degrees of crank rotation will it continue to look for knock? Those are settings are kind of handy to filter out noise and things like that. Knock coolant scaling. This has to do with if you're using the internal knock filter, not the normal external ESC module. And you can change the sensitivity of how it senses knock based on the coolant temperature. And of course, this is the standard Spark Advanced table with you have your two axes, the load, RPM. You can click on these, change them whatever you want to change them to. If you have this table set up just the way you want and you decide that you want to change an axis, maybe you want more resolution somewhere than somewhere else, you would click this button. I went over this before with the fuel table, but it's the same with this one. You can make your changes. Maybe you want this to be 52 or 54, for whatever reason. When you're done, click this button down here and it will interpolate. In other words, it will change the values in the table. It will move them around so that it's still correct. It will still run the way you had it before. And that makes it handy if you want to make changes here and you don't have to then try and reconfigure this whole table on your own. So there's the Spark Advanced table. Spark calculation summary. This is just like the one I showed you for the fuel calculation summary. In other words, at the bottom is the final ignition advance that actually is the motor will see. This is everything that goes into the calculation. I won't go through them all, but here's the spark table. That's the main spark table. These are optional spark tables for other situations. Here's the MAT retard we saw. There's launch timing. It adds it all up. Here's knock retard, and it can be handy if your spark advance isn't what you set it to be on the table, and you're wondering what's changing it. You can go through all these and see what's actually affecting it. So we'll move on to startup and idle. There's a lot on here that you won't need to change because it's set up specifically for the Buick and for this ECU. This table here is one of them. It just decides, when it's cranking, do you want it in batch fire mode, where clear flood mode should happen. Clear flood mode, if you aren't familiar with that, if for some reason you think the motor is flooded, like you've got too much fuel on the plugs and it doesn't want to start, when you push the gas to the floor, if it gets over 70%, it will turn the injectors off and you can crank it and it'll help dry things out. Let's see, most of this other stuff, like I said, this has to do with cranking fuel and how the cranking fuel can taper out if you have a long cranking time. Ignore MAT correction during ASC. That's during the after start fuel. When you first start the motor, you can tell it to ignore the MAT, and this helps get rid of any problems if you have a heat-soaked MAT sensor. If the engine is hot, it isn't too lean during startup. There's a capability to put priming pulses in. Basically, that means as soon as you turn the key on, it'll squirt some fuel in. It's extremely rare that you need that for the Buick, and so we usually leave that at 0.1. You cannot set that to 0. If you set it to 0, then the priming fuel that normally happens when you turn the key on, you have a couple seconds where the fuel pump comes on. If you set that to 0, you won't get any priming fuel. So there has to be a number on here. So we just set it to 0.1, so it's very small. Cranking pulse. So this is how much fuel gets squirted in while you're cranking the car trying to start it. And the colder the engine is, the more cranking pulse you'll need. Most of the time you don't need to mess with this too much. However, if you're running E85, it can be pretty finicky about how much fuel is being squirted in, and sometimes you need to play with these numbers. These are percentages. In other words, this isn't an actual pulse width of fuel like some other ECUs. This is a percentage of the base pulse width, which we set here. And what's nice about that is if you change injectors, this number changes, and therefore this will change because it's a percentage of that number. So many times when you change injectors, you'll find that you don't need to do much with the cranking fuel. It'll be pretty close as is. But if you have E85 and it's taking a little bit long to get the motor started, you can try increasing these numbers. You'll have to look at what the coolant temperature is while you're cranking and see if that helps. Cranking fuel taper curve. You probably won't need to change this, but it has to do with when you start cranking, you initially will get the full fuel from the cranking pulse table. But then as you keep cranking, it slowly reduces the fuel, and this is to help prevent flooding the motor if you have a long cranking time. After start enrichment. So there's two types of warm-up, we'll call it, fuel. And let me see if I can move that. There's after start enrichment, which we'll call more or less a short-term enrichment, and the warm-up enrichment, which is more of a long-term, which is based on coolant temperature. If you've ever had a vehicle that had a choke, that you had to pull the choke and turn it on right when you started it, and then you kind of turned it off after a minute, that's what the after start enrichment is. It's basically the choke. And so you set up these numbers so that when you first start it, there's an extra amount of fuel that needs to occur, and then it will fade out over time. And that is set by the after start enrichment taper. And this says how many engine cycles it will spread out that taper. So the higher the number is, it will take longer for the fuel to that extra after start fuel to go away. So the other part of the fuel is the warm-up enrichment, and this is based on coolant only. So and again, that will be higher when the engine's colder, and as the engine warms up, it'll slowly come down to 100, which is nothing at normal operating temperature. This section in here has to do with the controlling the IAC motor, and the idle control settings here dictate how to control the idle control the IAC motor, and so I'm not even going to show that because you don't need to change any of that. Just leave it alone. This operates in closed loop at idle. It monitors the idle speed based on this table. This is the idle speed that you want based on the coolant temperature. So down here would be your normal operating range, and the idle speed that you want. In this case, it's set to 825 RPM. And it operates in closed loop, and also when if it senses load, it will increase the IAC. Basically, it'll operate just like the factory computer. The cranking duty steps. This is how far open the IAC needs to be during cranking for your particular setup. The way I set it up in here is pretty typical for what we used it with the stock computer, and it usually works pretty good. If you have a situation where you're starting it and the idle flares up quite a bit higher than what you want when it's hot, usually you don't have that problem when it's cold. But when it's hot, let's say 180 degrees, you can reduce this number a little bit, maybe try 130 or 120, and so that when you first start it, the idle air control motor isn't open so far and you don't get that huge flare. Closed loop idle settings, again, you don't need to change much on that screen unless you have a specific situation. That just, again, it has to do with how it controls the idle air control motor. The closed loop idle initial values. When you first start the car, it will first look at the cranking steps. And then once the engine starts, it will drop to what's on this table. And it's based on what your target idle speed you wanted it to be. Let's say if the engine's cold. So let's say it was 1200 RPM. And over here is the coolant temperature. It will drop to this number, the IAC will. And you can use this table to kind of dictate how, when the engine's warming up, where it first sets the IAC to. Also, when you are driving and you let off the gas, it will initialize to this table also. It kind of takes some trial and error. You can take some logs and look at it and see what your idle is doing when you're driving and letting off the gas. But you know, I tried to set this up to work for most cars, so that you don't have stalling and things like that. But it's something you kind of have to watch and look over and see what works the best. Air conditioning idle up. What idle up means is this will show you how to control the air conditioning and what to do with the IAC motor when the air conditioning comes on, and things like that. So up here is set for this specific ECU on the Buick, and there's inputs that are the AC request, from when you turn the air conditioning on, what signal comes into the computer, and also there's an output that goes back and tells the AC to go ahead and turn on. Some of these you don't need to change. Idle up steps. So now here's a situation where, let's say when the AC comes on and it really tries to drag the idle down, you can have it add this many idle air control steps to help prevent that. It's something you have to experiment with. Seems like the different cars have a different amount of load on the AC compressor. And if you want the idle speed to increase when the AC comes on, here is, do you want the AC to turn off over a certain throttle position? Usually you do. When you start, if you go to full throttle, you'd want the AC compressor to disengage. I have it set to 60%. There's a setting for if you want it to turn off based on mile per hour. Usually you don't want that. But there is an RPM shut off, which we have set to 4,000 RPM. So if it ever exceeds 4,000, the AC will turn off. Down at the bottom, idle advance. This has to do with spark advance, and only at idle. This allows you to set like a fixed advance at idle. I have that turned off. It uses this table when you're idling. But I do have the idle RPM timing correction turned on. What that is it helps the engine maintain a stable idle. Let me go to that, and it's based on this table. The bottom row is RPM delta. In other words, delta meaning change. So if the idle speed is 25 RPM lower, when it says minus, is lower than what your target is, this box above it, it'll add or subtract timing based on how you have it set up. I have it set up so that if it starts getting even lower, if it drops to 50 RPM lower than your setting, it'll add 2 degrees of spark advance, which will help bring the idle speed back up. If it keeps getting worse, you can see, or I have it add more and more spark advance to help save it from stalling. If the idle speed is a little too high, I don't do a whole lot for that, just a little bit. There's no particular reason to get concerned if the idle speed gets a little bit too high. It's mainly if it gets too low and the engine wants to stall. But this is something you can play around with if you want to. I don't add a whole lot. I usually let the idle air control motor do its job, and it usually works out pretty well that way. And idle VE, I generally don't use that. There's probably some situations where you might want to use it. Basically what it is, if you turn it on, then when the engine is idling, it'll use this separate VE table. Maybe it'll help, helps you fine tune exactly what you want under those conditions. It's extremely rare that I've ever had to use that. All right, so I see we're at about 20 minutes already, so I'll stop there, and then in the next one we'll go through acceleration enrichment, boost settings, and we'll just keep going down the list there. So thanks for listening.